If you're taking the ACT, then you need to know 3 properties of logs. Those properties will help you so much in a question like number 45. Before diving into the question, let's actually do a quick review of those 3 properties. Okay, first, anytime you are subtracting 2 logs, like this example here, what we can do is actually condense those 2 logs into 1 log by using division. Remember, you need the same base on the left-hand side here in order to do that. Second, anytime you are adding 2 logs and they have the same base, you can condense those 2 logs into 1 log by using multiplication. Just like the first example, we need the same base in order to use that property. I'm saying it twice because we need to emphasize it. The final property is if we have an exponent, just like log 4 squared, we can take that exponent and we can move it in front to the coefficient position, just like that third example here. Now let's go back to the example that we started with so we can see these properties in action. Question number 45 clearly is dealing with logs because we see the word log in the table. The question then asks us to calculate the value of log 3 times 10 to the 5,000. If you're on the test and you see a question dealing with logs and a question dealing with multiplication, I want you to think about applying those properties that we just reviewed. So as a first step, what we could do is actually break this apart and say log 3 plus log 10 to the 5,000. That seems to work out well because then log 3, we can calculate that using the table above. Log 3 is equal to 0.5. Now we turn to log 10 to the 5,000, and what we can do here is move the 5,000 to the coefficient place. Therefore, we have 5,000 times log 10. You can calculate log 10 on your calculator. Log 10 is equal to 1. So putting this all together, we have 0.5, which was log 3, and then we have 5,000 times 1, which is just 5,000. Therefore, we add those together per that property, and we get answer D. The answer is 5,000.5. Comment ACT Math below for a chance to win 3 hours of one-on-one tutoring with yours truly.